afternoon, good evening, and possibly good morning, wherever you are. Thank you for taking the time to join us. And I'm going to share with you, it's really a technique rather than a tool, which myself and my colleague Andy Geddes have developed and we've started to use to tie together the knowledge silos between the IT world, the control system world, and the process world. So we're really trying to integrate how you understand and how you manage the threats to logical assets and the potential impact it may have on physical assets. And I appreciate that some of you may not necessarily come from a process safety background or a process background. Please think of this as asset integrity. It's simply the integrity of your logical assets and how that impacts on your physical assets. And those assets could be aviation related, marine, transport. What we're really trying to do is to get a holistic view using BowTieXP and some of the features of BowTieXP to make sure that the challenges are properly understood and addressed. So I'm going to go through the slides, then show you some of the key aspects of the software, and then we can come back and go through any questions that you may have. So fundamentally, we're targeting this at industrial automation control systems. This isn't about hacking your phone or your bank account or your Instagram account. It's based upon recognized good industry practice, primarily IACS 62443. That has been interpreted by the UK Health and Safety Executive in some guidance, OG0086, which primarily they issue to their inspectors, so they are fully briefed on emergent technology, but they make these operational guides accessible to anybody, so you can follow the links there. You'll get it on the slides, and it's got some really practical guidance on how to evaluate your cybersecurity vulnerabilities. We also make use of the UK National Cybersecurity Centre Cyber Assessment Framework, or CAF. Again, that's available to anybody. It's not specific to any particular industry, but it's a simple self-assessment framework that we've used to determine barrier effectiveness. And lastly, for detailed risk assessments, we've used the US NIST guidance that allows us to delve more deeply into threat likelihoods. And we're using this to ensure that electronic and programmable electronic threats are properly understood across all the stakeholders, not just the IT specialists or the operational technology specialists. And one of the key drivers is the second edition of the Functional Safety Standard 61511 now requires you to do a security risk assessment. So we believe this technique will help to address that requirement, to better understand the relationship between the bits and the bytes in your control system and the pipes and the pumps on your plant. So this is a simplified view of the cybersecurity management system framework that's in 62443. We are focusing on the high level and detailed risk assessment, so making sure you understand your risk reduction requirements, your what you've got to do to be safe and stay safe. You'll see here there are familiar policies, management procedures to make sure that all users of IT/OT systems are fully aware of their obligations not to allow unauthorized access or external breaches. Making sure the right countermeasures are in place and stay in place through maintenance, management of change, etc. And for those of you who are familiar with the Bowtie technique and the Bowtie software, fundamentally it's about barrier management. It's about understanding the context of your critical measures, where they're important, why they're important, and through the lifetime of the facility to maintain the integrity or the performance of those barriers. So it very much aligns with quality management systems, safety management systems. So making sure that you've got these appropriate measures in place, they stay in place, and you're monitoring their performance. So starting off with a really useful quote from the HSE OG0086 guidance. Fundamentally, you can't defend what you don't understand. You really need to be aware of what you're defending, why you're defending it, and how you're defending it. And as I said earlier, we're looking at two different assets here. We're looking at physical assets, the unit operations or major equipment on your plants or processes. And these are important because they could lead through loss of containment to a major accident. And then you have the logical assets, the industrial automation control systems that control, supervise, protect your physical assets. And they may be vulnerable to attack or degradation that could lead not necessarily directly to a loss of containment, but a loss of control could lead to losing an essential service, water supply, power, telecommunications, etc. So although the health and safety executive's objective is to focus on primarily major accidents, the UK government is sensitive to the more strategic needs of making sure that the lights don't go out. So there are frameworks in place to make sure that critical infrastructure is protected, that shutdowns are avoided, and releases and incidents are eliminated. So to try and bring some context to the assessment, we start off with a simple scoping and screening exercise. So in this example here, this is from the Bunsfield report representing the Bunsfield tank farm before it suffered a fire and explosion in 2005. We've got a familiar plot plan looking down on the facility, different tanks, different assets in place, and we can summarize or simplify that using a topological representation. So simply representing the major equipment, in this case it's tanks. So these are effectively physical nodes that are connected through major pieces of pipework. This is one tank farm, another tank farm, some export system to road tankers, some pump system to Heathrow Airport to deliver aviation fuel. So we've taken that literal representation of the physical assets and made it a much simpler topological view. Once we have that view, we can then overlay on that what our major hazards or major concerns are. So using a simple color-coded categorization, we have potential major accidents, loss of containment. If your facility was associated with power generation or other infrastructure, you may be concerned with either local or national loss of essential services. We're obviously aware of environmental problems, and we have to make money, so we're aware of commercial and reputational damage. So these can be simply color-coded, either red or grey, depending whether such a hazard is applicable or not, or in a more granular format, is the scale of the hazard high, medium, low, or not applicable. So this gives us a dashboard effectively of our physical assets and where we know, or we should know, possible hazards may exist. Another example here, this is a typical gas treatment facility where you're separating the gas from liquids. You're then treating the gas, disposing of the liquids, and sending it forward to some pipeline system. But the important thing to mention here is below we have all these utilities. We have boiler systems, steam systems, power generation systems, compressed air. All these may play a part in your own essential services. So we want to make sure that when we consider the scope of our risk assessment, we're not just looking at the big bang items, but also on the ancillaries, the things that maybe don't lead to loss of containment, but could interrupt production. Going back to the physical logical representation of Bunsfield, what we've now done is we've overlaid the industrial control system zones. So here we have zone 6. This is a safety instrumented system that is protecting these tanks. This cyan color is a different IACS zone, which is controlling these tanks. Down here we have another zone, zone 7, a combined control and safety system, which is overseeing these tanks here. And these two export terminals or export gantries are overseen by some other localized PLC system. So this gives us an immediate sense of the interfaces between our logical assets, our control systems, and our physical assets in the form of the tanks. The alternative view is to look at it from the control system perspective, and the HSE guidance OG0086 has a number of representative diagrams of what a system architecture may look like for a small, medium and large site. What we have here are a number of different logical assets, servers, firewalls, backup systems, etc., that are assembled into zones. And between those zones, we have a number of conduits, and these conduits allow data to be exchanged, but more worryingly, they allow attacks to propagate. So a breach in one zone can travel deeper into the system through these conduits. So it's important to understand the breadth and the depth that an attack could travel. And although the OG0086 representation is useful, there's a lot of unnecessary information here. We don't need to know that this has 4 screens and a keyboard. We don't need to know this has 2 screens and a keyboard. We could use the same topological view and represent them simply as nodes, blocks of logical assets that are collected together in functional zones. These zones are connected together via these conduits. So this is zone 1 and zone 2. So this is a conduit between those two. This is a conduit between zone 2 and zone 3, etc., etc. So we've now got a more clear overview of our logical assets. And down the bottom, this is where the logical assets interface with our physical assets. So underneath, we've got our various tank farms or tanks, which are communicating with our lowest level OT, operational technology infrastructure. If we now superimpose those hazards or those hazard consequences, the major accidents, the loss of essential services, environmental and commercial, we can now see where the most critical physical assets interface with our logical assets. So we can use that going forward to give us a contribution to our risk assessment. In terms of assessing the risk, we need two components. Typically, we need the consequence or severity, and we need the likelihood. And because technology is evolving, both good and bad technology, predicting the potential for a future attack based on previous historical data is quite challenging, because attackers are getting smarter. Conversely, duty holders are becoming more aware, so they're more resilient. So because of that uncertainty, what we've done is we've used the National Cybersecurity Centre Cyber Assessment Framework and categorized the vulnerability or the capability of your systems with these four major components. How well are you managing security? How robust is your protection? How reliable is your detection? And how do you recover and restore from an attack? So in the cyber assessment framework, there's a number of objectives, different objectives for different categories, A, B, C, and D. Depending on your self-assessment, you either achieve, partially achieve, or don't achieve those objectives, and that gives you a sense of your vulnerability. We then use that vulnerability to infer the likelihood that you will experience some kind of logical attack or logical breach. So superimposing those vulnerabilities, those cyber assessment frameworks vulnerabilities onto our logical assets, we can now see where we should be most concerned. Combining that with our physical asset consequences, so where we have a high consequence and high vulnerability, we have a high red risk, and low consequence, low vulnerability gives us a low or green risk. So that's giving us a dashboard or some oversight as to where we should be most concerned and where we should most focus our efforts. And you may already be aware of those. It may be common sense to which parts are vulnerable, but doing this in a simple representation is, like the bow ties, a much more simple and clear language that you can engage everybody with. So moving from scoping and screening into the actual risk assessment itself. So the conventional bow tie from a process safety perspective is that you've got some hazard, some operation, activity or material that can cause harm. You control or contain that hazard, but when you lose control, the top event occurs and you have the potential for negative effects or consequences. The top event can be caused by a number of different threats, and you aim to prevent those threats becoming the loss of control by prevention barriers or countermeasures. And if and when you experience that top event, you aim to reduce or avoid the effects through mitigation barriers. So from a cybersecurity perspective, at the heart of it, you've got critical or sensitive or valuable data that you don't want to lose control of. You don't want it to be stolen or compromised or manipulated. So you put in place resistance measures, you put in place this detection and protection so that you don't experience it, but God forbid, when you do experience it, you've got that recovery in place, you've got the ability to get your data back up and get your facilities up and running with the minimum amount of disruption. So if we look forward to how that would appear on a process safety bow tie diagram, this is just a very simplified view. We've got hazardous material, we lose control, it could lead to harm to personnel through a major accident. It could lead to commercial problems through production interruption, or it could lead to damage to the environment. We have measures in place to prevent or mitigate them, but these measures may be vulnerable to either deliberate or accidental attack. So barriers that are related or connected to industrial automation control systems can be defeated or degraded. Or we could have threats that are created as a result of the attack, or existing threats become more likely because of that breach, because of that loss of data or integrity control. Now, the start for a self-assessment is, in our case, we've taken a specific appendix from OG0086, which has 11 familiar or most common threat types. Most of these are malicious or deliberate attacks on your industrial automation control systems. We've simplified that in a simple Bowtie format, and we're using the cyber assessment framework to identify the countermeasures that the HSE expect to see in place. So we've got barriers here, which are the countermeasures. We've got barrier types, whether they're protection or detection, and we've also got the threat types on the left-hand side. A really simple, we've called it a security hygiene check. Using this OG0086 Bowtie, you can simply evaluate the threats. Are they credible or not to my scenario or to my systems? Are the barriers present? Are the barriers absent? Do I actually know whether the barriers are there or not, or do I not really need those barriers? So a simple yes, no check is a really quick assessment of the robustness of your cybersecurity measures. And one of the useful things in BowTieXP is you can flag up any deficiencies by using these action post-its. So looking at your larger Bowtie, if you find this is covered in yellow or red post-its, you know that you may have assessed it, but you've still got some work to do to make it as safe and secure as it could be. So that's a simple hygiene check. The next step is to dig a bit deeper and to better understand the risk by considering the likelihood of attack and the effectiveness of the countermeasures. So the likelihood of attack we've taken from the US NIST guidance, SP 830, which again, it's all freely available. And depending on the capability or persistence of the attacker, depending on the relevance or attractiveness of your assets, then you can get a good sense of what's the likelihood that you're going to experience an attack, who's going to be interested in your facilities. So we use that to give us a threat likelihood. The barrier effectiveness we get from the CAF scoring. So depending on your answers to the questions, to the self-assessment questions, do you fully, partially, or not at all achieve those objectives? And that gives you a sense of the effectiveness of those barriers. In a few minutes, I'm going to show you how this works in reality using AuditXP, but this is a simple screenshot to show how you can implement the cyber assessment framework as a series of questions. You apply those questions, or you collect those questions in a survey, and then apply the survey to your system. So here we have 9 different systems or 9 zones within your automation and control system. So that question there, that B3.C, all those 9 surveys were all negative. I mean, generally when you look at the answers, they are more red than green. So that's giving you an immediate sense of my barriers, my countermeasures are not as robust or not as capable as I thought they were when assessed against this cyber assessment framework. Some are generally more positive than negative, but there are some weaknesses, and I'll show you in a few minutes how you get much more data on that from BowTieXP. Moving forward from your logical bow ties into your physical bow ties, so effectively a breach or a loss of control from your logical bow tie, your industrial automation control system, the consequence of that may become a threat to a physical bow tie. So it could lead to a loss of containment, in this case a flammable liquid, which if your barriers are not present or not performing, then could lead to these tangible consequences. These are real effects on people, on the environment, on your equipment, on your business. So we're chaining together these bow ties. Logical consequences become physical threats. Looking at this in a bit more detail, so this is an example of a zone. So this is a basic process control system zone. So we have a number of potential attacks or threats within the zone. They may be adversarial or malicious or deliberate, but they may be accidental. They may be structural because of equipment problems, or they may be environmental because you've got flood issues or lightning strikes or other things. So it's not just simply about the rogue nation states or the disgruntled teenagers in your bedroom. There are other things that could threaten your zone. The effects of that could be impacted on these physical assets. So these are individual bow ties for tanks, for example. So using the Buncefield example, these are all tanks in the Buncefield tank farms. The potential consequences, the major accident, essential services, environmental, reputation, etc., these can be scored on the diagrams, and those scores can then be aggregated to show the worst case outcome of a breach of that logical asset based on its potential outcome on these physical assets. So this bow tie chaining concept allows us to tie together these two bow ties, but also, which is really useful, this idea of zones being connected by conduits. Because we've got bow ties for each zones, chaining those zone bow ties together lets us see where an attack on this zone 5, for example, could be transmitted downstream to another zone, or conversely, an attack in another zone could pass through a conduit into this zone. So the bow tie chaining is not only logical to physical, it can also be logical to logical. And using the relationship diagram within BowTieXP, that can be summarized. It's a bit difficult to read, and you may need a microscope to get into the detail, but what it does show at a relatively high level, again, is the topology of it. It's showing that here, this system here has lots of interconnections, a bit like a tube map or a metro map. You've got lots of interfaces round about this bow tie here or this asset here. Less so coming in here. This is basically coming in from the internet, but you've got a sense here of the scale and complexity of the network that you are managing, that you are protecting, that you are defending. So taking that forward from the logical to the physical, we can identify on the physical bow ties where individual barriers are connected to logical bow ties. So here we've got these two barriers here that are influenced or overseen by a particular zone. So if we lose this zone 5, either deliberately or accidentally, then you've got a common cause failure. Both these barriers could be lost, and you've then got no protection or no prevention from this particular threat. Similarly, a breach of the zone could lead to a threat. It could disable a control loop or instrumentation loop, and that in itself could instigate this loss of containment and the effects of that. Another thing I'm going to show you later is how systems and parts are really powerful features of the software. So your barriers are made up of systems. Those systems generally are based on a detect, decide, and do, or detect, decide, and act concept. So your safety instrumented functions will have a sensor, logic solve, and a final element. Your alarms will have a sensor, a processor, and an operator or somebody else to carry out the action. What systems and parts allows you to do is to give you online status of the health of those parts. So if you lose a particular part, it could be the logic solve or it could be a sensor, that can then compromise the barrier, and the systems and parts overview allows you to see immediately when your barrier becomes unavailable, because it goes from green to red. So I'll show you that shortly. Before I move into the software demo, are there any comments or questions, any chats to Ariane or anybody else, anything that you want to know about before you see the software?
I don't see any questions in the chat either, so if no one's got questions, I just suggest we move on.
Okay, thank you. So here we have a set of bow ties. So I've created, again, using Buncefield as an example of a physical asset, using the HSE OG0086 architecture for our logical assets. I've created bow ties for each zone within the within our system. So here, this was the example I was showing you before. So here we have zone 5. Zone 5 is vulnerable to these threats: deliberate, accidental, structural, environmental. At a high level, you've got barriers in place that prevent the loss of integrity. Those of you who are familiar with Bowtie good practice will know that management technically isn't a barrier. Management is supporting or enabling all these other barriers, but for simplicity and just to align with the cyber assessment framework, I've shown management as a barrier, and I've just given these nominal effectiveness: poor, good, very good, just to give you a sense of color, just to give it a bit of variety. So previous or prior to losing integrity or losing control, you've got these primarily protection detection measures in place. Once you've lost control, you've got your recovery measures in place that should slow down or reduce the escalation from the logical asset through to the physical assets. And as I mentioned before, these physical assets have their own severity rating, their accident, environment, services, commercial. Those can be migrated back from the individual bow ties back onto this bow tie to give you an overview of what's the physical significance or the physical criticality of this logical asset. Down here, we've got the breach. So conduit 5.4 breach, that's basically a breach from zone 5 to zone 4 through that conduit. And then up here, we've got the reverse. So you've got somebody or something breaching zone 4, which is allowed to pass forward into zone 5. So here you see once zone 4 has been breached, you've got some recovery measures on the zone 4 side, which I've also shown on the zone 5 side, that are protecting or stopping it getting further into zone 5. So that's the logical representation. The physical representation is here. So I've simply, again, just showed some representative barriers from the CCPS Bowtie book, different combinations of humans and hardware. So having had a breach potentially from either zone 5 or zone 6, challenging the integrity or the containment of that tank, possibly leading to accidents, environmental damage, etc. So these severity scores here are aggregated here. They're then aggregated backwards towards the logical bow tie. So that's giving us a sense of the physical and logical criticality. Looking at this in more detail for the logical bow tie. So here we've got our 11 familiar threats. We've got the expected or the anticipated measures in place, and putting some more detail on it. Again, what is the likelihood of the threat? What's the effectiveness of the barrier? That's giving a sense of the robustness of our countermeasures. And here we have some actions to be implemented. If we look at this from an audit perspective, so using BowTieXP, I've created a number of questions. So these questions from the cyber assessment framework. So hopefully you can see that. So each of these objectives has a question. Do you meet the requirements partially, fully, or not at all? Depending on your answer, you get a positive or negative response. So here we have 9 surveys, 1 per zone. On aggregate, generally they're more negative than positive. The audit software allows us to drill into, if I want to see particular surveys, so I'm now down to 3 particular surveys. There's still, the 3 that are left are still very much negative. So I've got that sense of, I think I'm prepared, I think I'm ready for an attack, but the responses I've given or someone has given to my cyber assessment questions are not as reassuring as I would hope they would be. Then lastly, this is our major accident scenario. So this is a simple analysis. Again, I've used Bunsfield as an example. The Bunsfield report has a neat example of a layer protection analysis. So I've simply taken the LOPA example from the Bunsfield report, visualized it in a bow tie, and in this case I've categorized the barrier effectiveness: very poor, poor, very good, just to bring some color to the diagram. But what's really important is the relationships with the logical assets. So these barriers are connected to different logical zones. So any compromise to those zones will have an impact to the barriers. And the way that's visualized is through systems and parts. So this systems and parts view is showing me here that I've got I've got a system with 3 parts in it. If I go to this part here, So my barrier here consists of effectively 3 parts. It's a safety instrumented function. I've got a sensor, a high level switch. I've got a logic solver, which is in zone 6, and I've got a final element, which is an isolation valve. If I lose one of these components, so if I lose zone 6 because it's become compromised, I need all these 3 parts to detect, decide, and act. So therefore, losing zone 6 has now compromised this barrier, and I've now defeated this because of a cyber attack. If I look at my other ones, my alarms here, my alarms are slightly different. So in my alarms, my detect, decide, and do, I've got a zone 5. So let's make zone 5 healthy again. I've got a level switch, and my doing or my acting is an operator. So let's bring the operator back online. So I've now got my 3 parts that make this barrier healthy again. If, for example, I've got, let's just say, a smart switch, so I'm losing my smart level switch has been attacked. I've lost that functionality. I've now defeated that barrier. And the worst case is, if I go back to this, I've got a healthy level switch, but because both these barriers are related to zone 5, if I lose zone 5 because of a cyber attack, I've effectively lost both those barriers. So I'm relying on zone 6 still being intact. If I go here, I'll put zone 6 back online. So I'm relying on zone 6 being healthy to give me at least some form of defense. So that's the Bowtie chaining, that's the audits functionality within Bowties, and that's the systems and parts that's connecting the logical analysis to the physical analysis. So if I can resume where I was. So in conclusion, what this chase technique is, we're pulling together established tools. The screening and the scoping is simply done using Visio. We're using that to focus our efforts to develop logical bow ties for our industrial automation systems and physical bow ties for our processes and plants. We're using our existing risk assessment, so you already will have physical asset bow ties, your process safety bow ties, etc. But remember that some of your vulnerable assets, some of your utilities or ancillaries may not have a HAZOP, they may not have a process hazard analysis because they've not been deemed to be safety critical, but they are, you know, security critical or production critical. I'm not a cybersecurity expert, so what we've created is a framework to allow expertise in different areas to come together with a common framework, a common language, and pool their knowledge to visualize the scenarios, get a common understanding and a common approach. It can be done in stages. The OG0086 framework is very much targeted to major accident hazards, loss of essential services, but it could be a quality issue, it could be a reputational issue. It's the same technique, it's the same principles, and you can do it in a scalable, organic way. And fundamentally, we're pulling together these different parties, these different stakeholders, the information technology, operational technology, and the physical technology, the IT, OT, and we're calling it PT. My friend Rachel has neatly summarized all this in one neat graphic. This is all Chase is doing. It's pulling together physical and logical assets, chaining together knowledge through graphical representation. And ladies and gentlemen, that's all I have to share with you. If you have any questions or comments, please type away, speak out. We're open to your suggestions, your comments, your questions. So thank you for listening. Thank you for watching. Do we have any feedback?
Anyone? I don't see any questions in the chat. So if you have any questions later, please feel free to reply to the follow-up email that our event manager will send to you with the recording of the session and the presentation. So for now, you can ask questions, or you can ask them later via email if you all of a sudden think of a question afterwards. Yeah, so I think this is it. Already one person has dropped out, so thank you for your attention. And if you have any questions again, please ask them later. Thank you.